We can kind of segue into the cylinder head. If you look at the cylinder head here and see how this is what's considered the quench area, the cylinder head over here, combustion chamber. Obviously, the the 6 cylinders have the intake and exhaust port is on the same side. So your intake charge comes in here, fills the cylinder, the spark plug lights it off, and then of course the exhaust valve opens and it pushes it back out. Well, you want the chamber area or the flame area as small as possible, because when the fuel and air mixes, it only will burn at 14.7 to 1 air-fuel ratio. Whatever air and fuel that's in here that's exactly mixed at 14.7, that's the only stuff that burns. So you want to keep that area as small as possible. So what you do, if you look at this piston and that piston there, they both have flat areas here, and then what they consider a reverse dome. This dish in the piston, closely as possible, mirrors the chamber of the cylinder head. So it pushes all the air fuel into what we call the quench area of the piston or the cylinder head, and then this area here is a dead area. So you take that area, which is quenched, because when it comes up it gets really close right there, and it pushes that air fuel back over into the chamber and keeps it in as small as area as possible, so you get the most efficient burns.
You've got a trail running Jeep, and folks basically want fuel efficiency. It's a major concern with the cost of fuel.
Sure.
So your objectives then in establishing the correct quench and building a cylinder head and a piston and block deck configuration that will work best to meet those objectives, what do you do?
Well, you want to run the piston as close to the top of the bore as you possibly can. Most head gaskets are about 45 thousandths. So I can tell you right now, because I've run them, steel rods in general, stock steel rods at 6,000 RPM stretch 40 thousandths, okay? So if you have close to a zero deck, 45 thousandths head gasket, that keeps you about 5 thousandths in the safety zone of the piston not hitting the head. Okay, so you want to run that as close as possible, again, to push that air fuel back into the chamber, so it has the smallest area for that spark plug to light it off.
Okay, and in your experience with engines, and you've built quite a few racing engines and emphasized that, and they've been national drag car engines and have won class records and everything else. If you want this engine to stay together for a long period of time, either of these engine configurations, and we'll get into in a minute if you have a preference for one over the other, what is your objective for making this engine live? Like
we talked earlier, Moses, our shop has very similar equipment, if you will, to a lot of shops in the country. There's about 200 of us across the country. I've checked the numbers. There's about 200 automotive machine shops. What we try and do to set ourselves apart from most of your other shops is attention to detail. Attention to detail and making sure that the components work for the person's application. Both of these guys have what we consider low RPM, considering some of the other stuff we do. Low RPM, high torque style engines, okay? So we want the piston to wall clearance perfect. We want the quench or deck clearance that we just talked about perfect. We want the bearing clearance perfect. We want the oil pressure perfect. We want the guide clearance in the head perfect. We want the springs set up perfect to match the camshaft, which they are. So that when we put this engine together, it's not fighting itself, it'll run smooth, and it'll run a long time. You know, these engines aren't made to come apart every time you take them out, not like that thing that's made to come apart all the time. You know, you make run one weekend and then you take that kind of engine apart. That's not the objective with these. We want these to run a long time. You have very good fuel, as best fuel mileage as we can. And the other thing you gotta understand, an engine that gets good fuel mileage makes really good power too, because the more well-tuned and the more efficient the air fuel burns in the engine, the better fuel mileage you get and the more power it'll make. We run mainly in street applications because the unleaded gas, stainless steel valve with stainless steel stem, and steel valve guide, okay? Run the clearance about a thou and a half to a thou 8 on the intake, a thou 8 to 2.1 on the exhaust, okay? That gives you the most longevity, will get you a real good mileage out of it. Then we take, these actually has a 3-angle valve job on the intake, and it has what a lot of guys consider a multi-angle valve job on the exhaust. We actually put a 45-degree seat, 30-degree top, but it actually has a radius bottom. Underneath the valve seat on the bottom, we actually radius the seat. That works the best for the exhaust. That picks up the flow a ton. It picks it up probably 20%. So that's what we like on the valve job on this. This head is not ported. We do lots of porting work, but this gentleman, like I say, this is a low RPM deal. The porting work really wouldn't give you much bang for your buck, so I don't know that it's necessary on these style engines. And then of course the valve spring is matched for the pressure for a hydraulic cam. This has about 90 pounds on the seat and about 280 pounds open, which is perfect for our CompCams hydraulic cam that we talked about before.